These are the very important things in this particular thing, the applications of the Newton's laws. Motion of the body on a rough surface, horizontal and inclined surface, and the block on a block problems. So these are going to be the very important things, please. And coming to the Newton's laws of motion here, applications or anything. So in the first law is going to the Newton's explain the regarding the force condition, that is the body continues to be in the state of rest or in the uniform motion case here. So there he will be explaining the force, that is F is equal to, and in the second law it was been mentioned that F is going to be, or the external force is going to be rate of change of momentum dp by dt, or this can be written as a d by dt of, this is mass into velocity. So from this one it can be written as an m is constant, then it will be the dv by dt, and if v is constant, then it will be the dm by dt. So for a given situation, if m is constant, then your second term will become 0. Then the force can be written as, and this is m into the rate of change of velocity, that can be written as an EMA. So there are a lot of applications concerned to this. One of the basic principle of this particular force, and so concerned to the third law. So for every if force, there will be an equal and opposite force will be existing. Forces always exist in the phase conditions. So the basic examples for that one you can go in this case are the, suppose a person has been standing in a lift and the lift is in the stationary conditions. This is an apparent weight conditions. So if the person has been standing over here and he is in the rest position and the lift is in the rest and the lift is in the rest, then the apparent weight of the person is, that is weight W is equal to, simply it will be the mg. Now if lift is accelerating in upward direction, then with respect to the ground or with respect to the accelerating frame of reference or anything, then the apparent weight can be written as an m into, this is mg plus ma, or it will be m of g plus u. So if the lift is coming in the downward direction in this situation, that is if lift is coming in coming downward direction with acceleration a, then apparent weight can be written as, and this is m into g minus a. So these apparent weight conditions will be using in the lot of situations. In the different chapters also we'll be using. Or the general terms of the food machines if you want to go, or the connecting bodies. For example, there is a pulley sort of a thing which is being hanged on the one side with a mass of here m1 and another side with a mass of m2. Then these things can be applied by the Newton's relation. Upward forces are going to tension, downward forces are going to be the m1 g's here. Then you can go for your resultant force if it is been accelerating, or if m1 is greater than em2. Let me take this condition. In that situation, it will be coming down with an acceleration here, and this will be moving upwards with an acceleration here. So these sort of a connecting bodies, you can find the acceleration will be here, that is m1 minus m2 by m1 plus m2 times of g, and the tension in the string can be written as, and it is 2m1 m2 by, this is m1 plus m2. So please go through all these connecting bodies, how you will be obtaining the acceleration part and the tension in the string, or the resultant force conditions, please. So for example, this is the normal thing for a force conditions. where the force F is equal to Bindle relation is equal to, that will be your MA. So now coming to this one, a bullet of mass 0.1 gram is there, is fired into an wooden block here. So consider an wooden block here. Now a bullet is being fired into this wooden block. Okay, now, but it stops after moving a distance of 50 centimeters. The bullet pierces itself and it is traveling some 50 centimeters, and here bullet has stopped. Okay, so if the velocity of the bullet before hitting the wood is, so here velocity u is equal to 10 meter per second. Your final velocity v is equal to 0. Slows down with a uniform deceleration. He is asking the magnitude of the effective retarding force. There is a force on the bullet that is acting opposite to its direction of the motion, which is called as your retardation force here. So on the bullet is x. He is asking what is the x newtons. So bullet is being stopped when it is penetrating into this one at a distance of. So displacement or distance is equal to 50 centimeters, 50 into 10 to the power of minus 2 meters. Initial velocity you have got 10 meter per second. Final velocity is equal to 0. So we can find the force. To find the force, basically what you need, mass and acceleration. Mass is provided in the question, acceleration is not there. From these values, you can get the acceleration. V square minus u square is equal to 2a. Yes. V is equal to 0. That means 0 minus, this is going to be the 10 square is equal to, it's a retarding, so acceleration will be negative a into displacement is 50 into 10 to the power of minus 2. So solving this one, you should be getting your acceleration a as something like this is 100 meter per second square. Okay, so substituting this in the force of this, or the retarding force of this one is equal to ma, mass is going to be 0.1 kg and acceleration is 100. So this will be the 10 newtons. So this is going to be our answer, sir. Next one. So motion of the body on a rough horizontal surface. So and inclined plane also. So consider a body is there which is placed on a rough horizontal surface. What will be happening here? Suppose it is been moving with certain already moving with an initial velocity u. Since it's a rough surface, the friction is going to be acting in the backward sense. And because of that friction, which is mu into normal reaction, can be written as an ma is equal to this is mu into mg, and the acceleration opposite to the direction of the motion because of the friction will be this much. So this will be acting in opposite direction. Then, so after how much distance it's going to be stopped and all these things. So in this situation, if it is already having the initial velocity, then after traveling some distance, if the block stops, then final velocity will be 0. In that situation, if we apply V is equal to U plus AT, then 0 is equal to U minus mu G into T. After a T is equal to U by mu G seconds, the block will stop. The block will stop here. And after traveling a distance of yes, so that means if I go for the v square minus u square is equal to 2a yes here, then it will be the u square by 2 mu g is the distance traveled before the block stops. Distance traveled before the block stopped. Okay. So now like this you can find out the things please in the horizontal motion, or else if a block is being applied with certain force on this one on this side here, and the mass is going to be the m, and on rough surface friction will be acting in this direction, then you can obtain the resultant force is equal to F minus frictional force. So this is F is the applied force. So if there is just a moment, I'll come to that one. So now if in this case some resultant force is left over, then the acceleration of the system can be your applied force Fa minus frictional force by m. If the surface is not a smooth surface, it is not a frictional surface, then there won't be any such force which is going to be objecting the motion of the body. That means the body is going to be moving without any objections with a certain uniform velocity, continues to travel until it is being stopped, as if in the case of an motion in a straight line case. Then obviously it's going to be continuing to move without any objection, no acceleration is there, no opposing force is there. Then the distance traveled can be written as n, that is u into t, you can go for it. And the time is going to be stopping, we cannot say because it doesn't stop over there. So distance traveled in a given time, you can calculate in this way. If it is accelerating situations, then you will be applying S is equal to ut plus half a t square. So this is the when there is no or on a smooth surface. Okay. So this is the case on a smooth surface. Now, so if this is the situation we have discussed in this case, if friction is there and there is some uh, applied force is there, then this will be your acceleration due to the friction case. Please. So now here also, when we are talking about the friction, if there is an applied force is there on this one, Fa, and your maximum static frictional force can be written as mu s into normal. In this case, it will be the mg. So if applied force is less than the maximum static frictional force, which is equal to the mu s into mg, then the body does not move. Then body does not move, but frictional force is equal to applied force. Fine. So this is the basic conditions. Frictional force will be equal to the applied force until it reaches to the maximum static frictional conditions. Okay. So now on this one, a body of mass m, 1 kg rests on a horizontal floor, which it has a coefficient of static friction as 1 by root 3. Okay. It is designed to make the body move by applying a minimum possible force. This is the one which is important, minimum possible force. F newtons, the value of the F will be how much he is asking. So here consider a block on this surface, please. So this is the block on a surface. Minimum possible force. So we are applying the force in this direction F, which is going to make an angle some theta with respect to the horizontal. So in this case, F cos theta is the one force which tries to pull the mass M in the forward direction, in the horizontal direction, and F sin theta will be acting in the upward direction. There will be an mg which will be acting in this direction and your normal reaction here. So F cos theta is completely responsible for the motion of the body, or F cos theta can be treated as your applied force. So minimum conditions means when the block is going to be just trying to move, So in minimum condition situation, in minimum possible force, applied force will be equal to the frictional force, that is Fa is equal to frictional force. Applied force is going to be the F cos theta and the frictional force is equal to mu into N. So in the vertical direction, the total upward forces, that is N plus F sine theta, since there is no motion in that direction, N plus F sine theta is equal to mg, or your normal reaction will be equal to the mg minus F sine theta. Substitute this particular value here, that will be the mu into. This is mg minus F sine theta here. So take the F to the one side, please. That is F cos theta plus mu into F sine theta is equal to mu times of mg. From this one, we need the minimum force, so F can be written as an cos theta plus, that is mu sine theta here, is equal to, that is going to be the mu into mg. So on that sense, your minimum force can be calculated by the mu mg by, this is going to be the cos theta plus mu into sine theta. Fine. So, but since they are just moving conditions, that is applied force is equal to frictional force, then your coefficient of friction is equal to angle of the friction, that is a tan theta it comes out to be. So if mu is equal to tan theta or tan theta by 1, then what will be a value of the sine theta, sir? It will be the mu by root over mu square plus 1, that is opposite side by hypotenuse, and corresponding cos theta can be written as an 1 by root over, it will be the mu square plus 1. So substitute these particular values in this relationship. So F is equal to mu mg by cos theta can be replaced as an 1 by root over mu square plus 1 plus mu into, sorry, this is going to be the sine theta here. I'm carrying right down the mistake. It's going to the mu by root over, that will be the mu square plus 1, or you are solving, you will be getting it as an, this is mu mg by, it will be root over mu square plus 1 over here, because I'm going for an applied basic conditions, so minimum conditions. So for the force to be the minimum, so we have given the values. Coefficient of friction is 1 by root 3, mass is 1 into 10 by root over, this is 1 by root 3 whole square plus 1. So on solving this one, 10 by root 3, I should think you should be getting it as an, on rounding this one, you should be getting the value as an 5 here, please. Okay, so these are your thing for the minimum case here. Next, so this is your block. Okay, one thing I have skipped up was right. Next step is going to be the, so block on a block. Before going for the block on a block, I would like to discuss the things on the friction on an inclined plane. For example, the forces on inclined plane condition, there was, so if a body is trying to slide down an inclined plane, which is making an angle theta with the horizontal, a rough surface in this case sliding down with a mg sine theta, and your friction will be acting in the upward direction here. In this situation, the acceleration, or when the when the mg sine theta here, the applied force is mg sine theta, when the mg sine theta is equal to maximum frictional force, in the sense maximum static frictional force. That means your mg sine theta will be equal to the mu mg cos theta, and you call this situation where the tan theta is equal to mu is called as your angle of repose. In this case, if body slides down, if the body slides down here, then acceleration A can be written as an g of sine theta minus mu k cos theta since it is coming down. And if body slides in the upward direction, then acceleration A is equal to g into sine theta plus mu k cos theta conditions, please here. So these are your situations, ma'am. Okay, fine. So in this one, the velocities and your accelerations can be calculated here. So the velocity of this one, I'm not going for the block on a block now. Okay, so I might be taking another case, please here. Yeah, 1 second. Great. So acceleration A is equal to g into sine theta minus mu cos theta, please. Yeah. So A is equal to, this is the one of the relations, sir. Excuse me, it's skipping over here. Yeah. So velocity can be calculated considering the initial velocity u to be 0. So that will be the v is equal to root over, it can be calculated, that is 2gl of, it is sine theta minus mu cos theta. So when it is sliding down, similarly when it is moving up, here the sign will be converted, and the time taken to come down of a rough inclined plane can be calculated. 2l by, it is the going to 2l by g of, it is sine theta minus mu cos theta here. So when the block is coming down, this also. So these are the different cases which will be needed when we are solving the sums in this particular situation. Okay, so when the block is moving up the inclined plane, we can say that when the block is moving up the inclined plane but an angle theta here, then the friction will be acting in the upward sense, in the downward sense along with the mg sine theta and your frictional force. Due to that reason, here the plus sign is going to be obtained for an sliding up case. Okay, so these are your major important things. So please try to remember them. Okay, all the relations and all the formulas, you can derive them also here. Fine. So next situation is going to be under this one is a block on a block condition. So coming to the block on a block, what there will be two situations. In the first situations, when there is a block placed on another block, suppose this is A, this one is B, I am applying a force on the upper block. Now what will happen here? Three cases. If applied force F is going to be less than, here there is the friction is there, mu, coefficient of friction, but here it is smooth. So if applied force is less than the maximum static frictional force, which is equal to the mu s into mg, what will happen then? A does not detach from B. So A will not detach from the B here, and both will move with the same acceleration, please. Okay, now so then what will be the same acceleration? Or if you want to have, you can write this one because this is the block diagram of this one. Force is in this direction. Then your frictional force is going to be acting in this direction, which is going to be less than. And on the block B, there will be the only force that will be frictional force, which will be acting in the forward direction, which is equal to the applied force because it is not exceeding the maximum limiting friction. Then F can be written as a capital M plus small m into A, or your combined acceleration is equal to F by capital M plus small m. So now in this situation, the second case, if the force applied is equal to the maximum static, that to frictional force, then the block tends to move in that situation's case. Then your acceleration of the upper block can be written as an mu m g by m, which is equal to the mu g, and acceleration of the lower block can be written as an only force is going to the mg by mass of the b. Okay. Now in the third case, if I go for the third case here, if your applied force is going to be greater than the frictional force. So this in this case, acceleration of the A can be equal to the acceleration of the B because they both are not separated because they are just equal and they are moving towards them. But in this case, where the applied force is greater than the frictional force, then the acceleration of the block A can be written as an resultant force, that is applied force minus mu into mass of the A into g by this is going to be the mass. This is the acceleration. And on the block B, only one force that will be acting, that is a frictional force, which can be written as a mu ma g by mass of the B. So both will be in a different senses, please. So this is how you need to separate. You just need to draw the block diagrams separately and deal them separately in the situations here. Okay. Now coming to this particular thing, block or a block question here. So it is a special question where we are applying the force on this one. So force is applied on the lower block. Let me first find the what is the maximum coefficient of friction between. So here he has given the coefficient of friction mu is equal to 3 by 7. Okay, horizontal table figure shows next one. Arranged on a frictionless table. So here the coefficient of friction only between the two blocks. Then the maximum force can be applied on the larger block so that the blocks has to move together. That means they should have common accelerations. So that also maximum thing. So when what is the maximum static frictional force will be equal to the that is mu s into mg or mass small m into g. Mu is 3 by 7. Small m mass is going to be zero point 0.5 and g value is equal to 10. Okay, so this is the relationship, please. So on that sense, we can go for the 15 by 7 newtons. So this, if I apply this one, so this is the maximum static frictional force. Now the small m feels as a force in the or an acceleration in the backward sense so that it feels that the acceleration with the mass, with the force of its mass, which is ma, such that if ma is going to be maximum case, it has to be equal to your frictional force. That means ma is equal to mu into your mg here. So now your maximum acceleration is nothing but the mu g. So if the force is applied F so that the acceleration is maximum, then obviously your force will also be the maximum force. So for that one, the applied force can be written as an because both of them are moving simultaneously. So both should have the maximum acceleration only. Then in that sense, your 4.5 plus 0.5 into what will be your maximum acceleration, that is mu into g. So substituting this value, which is 5 into mu value is 3 by 7 into g is with 10. Okay, that will be equal to your something as an, you can go ahead here. So that is 150 by 7 here. So which will be almost nearest to the rounding chair. He has asked us to rounding the approximately that can be your some other value. Just try to calculate and close it, please. So this is the situation, sir. Okay, then okay, fine. So this completes our discussion part. Now use this particular promo code so that you can get the subscription. On subscribing, you will be getting a lot more sums for the practice in this on the Rise platform. So coming to this particular case where the solid cylinder of mass m is wrapped with an inextensible string and is placed on a rough inclined plane as shown in the figure. The frictional force acting between the cylinder and an inclined plane, actually strictly talking, it is a combination of an or the concept of the force or the friction has been placed in the rotatory motion. It's a concept combination of a translatory motion and a rotatory. So we have to use both the situations in this case. So what are the forces that might be acting here? So this force which will be acting in the downward direction will be the mg sine theta. It is pulling it in the downward direction, so tension is going to be in this direction, and here friction between the plane and this one is also in the upward direction. Okay, now under the normal situation, under the equilibrium conditions in the sense, so I'm writing the first one, that is the translatory equation or for the translatory motion. So for the translatory motion condition, so what are the forces under the equilibrium? The upward forces are the tension and friction balanced by the downward portion mg sine theta. Here this will be your first equation. Now coming to the, I'll be using the rotational conditions. So for the rotational equilibrium, so one is the one, this torque is being produced here, net torque is equal to 0, or your tau net is equal to 0. That means clockwise torque is balanced by anti-clockwise torque. So who are producing the torque here, sir? So tension, the torque is producing because of the tension. This is going to be your R bar cross F bar. It is in the clockwise direction, and this R bar into frictional force. This is in the anti-clockwise sense. That is T into R is equal to frictional force into R. That is T is equal to F. So on substituting in the first equation, then what you should be getting, sir, this one is 2T, 2 into tension is equal to, that is mg sine 60 degrees by this. That means tension is equal to mg sine 60 by 2. Okay. So for this particular thing to not in the equilibrium, if mu into mg cos 60 comes out to be less than your mg sine 60, you can calculate and you can substitute the values and you can verify this one. So obviously, hence this cylinder is now more remaining in an equilibrium, just it is tending to move over there. That means your frictional force is going to be the kinetic frictional force, whatever it may be, that is mu k into mg cos 60 here. So which can be written as a mu k is equal to, or on substituting all the values, you have got the things, please, though this is going to be the mg by 5. Okay, so this is going to be our condition. So 0.4 in the sense, you can write it as an 4 by 10 into, this is mg by 2 situations here, please. Mu k 0.4, mu s value needs to be provided in this case. So obviously it's going to be the, so frictional force acting between this one, this can be mg by 5 conditions. Okay, that means it should be somewhere around 0.2. So which is the precise option is this one. Now in this case, a body of mass 4 kg is standing on a piece of the wood, where the piece of the wood having the mass 5 kg here. Okay, so this is the piece of the wood he is talking about, which is equal to the 5 kg. Probably it is unable to see over here. Fine. So this is the 5 kg. The coefficient of friction between the wood and the floor is 0.5. That means he has given the mu value is equal to 0.5. The maximum force that the body can exert on the rope so that the piece of the wood does not move. So for this particular thing not moving, that is, it is under the equilibrium. What are the forces that will be on this particular piece of the wood so that it cannot move? That means it's sum of the forces along the x-axis and the sum of the force is equal to sum of the forces along the y-axis has to be zero. So for this one, we need to identify the forces that will be acting on the system. So first one, a boy of mass 4 kgs is standing on the piece of the wood. So the mass of the boy plus mass of the wood combinedly 9 kgs are been acting in the downward direction. That means 9g will be acting in this direction. Then what are the forces? This is your a tension in the string in the upward direction. Along with that one, the normal reaction will also be in the upward direction. So this is the vertical forces. Now horizontally here there is a tension which is acting towards the right side T, and that should be balanced by your frictional force. Frictional force is equal to mu into N. Okay. Now let's apply first case, that is sum of all the forces acting along the x-axis is equal to 0. That means T minus mu into N is equal to 0. T value, what is the N value, sir? Okay, let's write that particular thing by getting the upward forces case. So equation 2, total upward forces T plus N is equal to 9G, which is equal to the 90 here. Then your normal reaction can be written as a 90 minus H. So this is your equation 2 or whatever it may be, the 1 here. If I take this as a 1, this as a 2. So substitute this 2 in this one. Okay. So when we substitute this one where the T is equal to mu into normal reaction, what is the normal reaction here, please? Which is 90 minus T. So now expand this one, mu value is 0.5 here. So that is T plus 0.5 T is equal to 0.5 into N or 0.5 into 90. Okay, so this is our situation, so please. So in this case, so when you solve this one, this is going to be the 0.9 into 0.5 into 90 case, so this one. So that means 0.5 into 90, this will be the 45. And here it will be how much? 1 plus 0.5 is 1.5 t is equal to. This is going to be the 45. So your final tension value, or in this case, T can be written as, and it is 30 newtons, please. On rounding off to the whatever the corresponding thing. Okay. So this is so 1.5 can be written as a 3 by 2. So 15 into 2 will be the 30 newtons. So your answer will be your 30, sir, please. Now, coming to the next question of this one. Body of mass 2 kgs moves under a force of 2I plus 3J plus 5K newtons. It starts from the rest. What do you mean by it starts from the rest here? Initial velocity should be equal to 0. And was initially at the origin, that means initial displacement x naught is also equal to the 0. So after 4 seconds, he is giving the time value where time t is equal to 4 seconds. After 4 seconds, what will happen here? The new coordinates are the 8 comma b comma 20. He is asking what is the value of the b. So from the force, can we get the acceleration of the system? So acceleration of the system can be written as an force by mass. Mass is 2 kgs, which is 2I plus 3J plus 5K by mass is going to be your 2, sir. So on that sense, this will be equal to the I cap or plus 1.5 J cap plus this is going to be the 2.5 K cap. So all of them are your unit vector situations. So we have got the acceleration where the initial velocity is equal to 0. I need to find out the displacement. S is equal to ut plus half a t square conditions here. So initial velocity is equal to 0. S is equal to your half into, substitute the acceleration here, sir. That is I plus 1.5 j plus 2.5 k. Okay, so this is the acceleration in a time span of 4 seconds. In the sense, it should be the 4 square. So when I substitute in this one 4 square in the sense 16 by 2, it will be the 8, sir. So your it will be the 8i. Yeah, 1 second. So it will be the 8i. Next one is going to be the 8 into 1.5. That will be equal to the 12j plus last term 8 into 2.5 will be your 20k. So on comparing the coordinates of the given one and this one, so 8 along the x-axis and z along z-axis 20. So your b value has to be how much, sir? That should be equal to 12. Okay, so this is your answer for the case. This is the 12. Next one, question number 4. A 2 kg object is placed on a frictionless surface. If the force acting on the this one is going to be this much, find out the displacement in first 10 seconds. So this is also the one of the same model sum. From the case, get the acceleration is equal to force by mass. Force is equal to 2 kgs. Sorry, mass is equal to 2 kgs. Force is 20I plus 20j plus 10k here. Okay, so this is divided by here. Mass is going to be the 2 kgs. So on solving this one, how much you should be getting, sir? So this is equal to the 10i plus 10j plus 5k. So you have got the acceleration, put it in the equation for the displacement where S is equal to ut plus half a t square. That is half a t square. So here the initial velocity, since the body is starting from the rest, consider it to be the 0. And next, when you put it down, then S is equal to, it will be the half into, acceleration is going to be the 10i plus 10j plus 10k here, 5k, sorry. So into your time interval is going to be the 10 seconds, that is equal to the 10 square. So try to solve this one, you can get, or you, if you want the magnitude, you can get it in another way also. Or this will be when you substitute, this it will be 500i plus 500j plus 250k. Okay, so this is our relationship, please. Axel, this is what the displacement is. Now, in this case, if he wants the block is being sliding down on a rough floor, please. The block of mass m is sliding on a floor while the force of the magnitude F is applied to it at an angle theta. Then which force is going to be acting in the horizontal direction? That is F cos theta. If I resolve them into the components, then in the upward direction it will be the F sine theta along with the normal force N here. And the mg will be acting in the downward direction here. Then in that situation, what is an acceleration? That means your applied force is greater than, that is F cos theta is greater than your frictional force. So in that sense, resultant force can be written as an F cos theta minus frictional force, which is equal to the F cos theta minus frictional force is mu into normal reaction. So from the diagram, you can write the normal reaction is equal to mg minus F sine theta. Substitute the n value here, then the resultant, the MA is equal to F cos theta minus mu of mg minus F sine theta, and take out the m, sir. Acceleration is asking F by m into cos theta minus mu into g minus F by m sine theta. So this should be your acceleration conditions where it is located. Yeah, so this should be, or should be a negative sign here, here also negative sign, right? Option B.